Hey guys, my name's Anurag. I'll be talking to you about Glue. I manage a handful of our data processing services here in AWS. Those are in sort of order that they've been released: EMR, Redshift, Aurora, Athena, and now Glue. So what I'm going to be covering today is why we're building an ETL service, what are the main components, what's different, and when you can try it out. So a relatively simple thing. I imagine you guys want to get out of here and get on towards the party. So I'll try to keep the session fairly short, but I'll be around to answer questions as long as you'd like. I also have a number of the members of the Glue development team here. They're the ones taking selfies. And so you can talk to any of us afterwards. So let's get into it. So why would AWS get into the ETL space? I mean, it's a messy, messy space, right? It's a fairly hard space for any of us to work on. And the fact is, all of us are in the ETL space. If you own the data warehouse, you're in the ETL space, right? We also have lots of ETL partners. So this is just a handful of them that are on the Redshift partner page. And there's a lot of fantastic technology vendors up there. And if you're using them, it makes a ton of sense. You should use them. The problem is, despite all of the partners, despite all of the investment that people are doing inside the ETL space, despite the variety of choice that's available to you, 70% of ETL jobs are hand-coded with no use of ETL tools. And actually, our estimate is that it's over 90% of the cloud, well over. And so how does that make any sense, right? Why would anyone want to hand code? It's brittle, it's error-prone, it's laborious. It's really, I often describe ETL as commute time. It's the time you spend getting to work as opposed to the time you spend working, right? And so, why would you want a long commute? You wouldn't, right? And the fact is, after you're done, you're still not done because you need to maintain your code. The data formats change, the target schemas change, you add sources, the data volume grows. All of those things, additionally make it brittle and laborious, right? And I'm sure you all live in this world. But the fact is, code's flexible, code's powerful. You can unit test code, you can code review code. You can deploy along with other code. So as you make a change to your JSON file, you can make a change to your pipeline that moves it into Redshift or your data warehouse of choice. And you know your dev tools, right? I mean, for a large percentage of our customer community, they spend maybe 5–10% of their time on ETL. They're full stack developers. They spend a lot of time in their IDEs. But it's still a problem, because ETL is the most time-consuming part of analytics. So particularly in the cloud, where we've done a lot to simplify the data warehouse, the BI tools, that's not necessarily where the value is generated, but it is where the time is spent getting things done, right? So that you get your data in. And because it's so laborious, you get dark data. You store a lot of data inside S3 or your sources of choice, but only a fraction of that data ever makes it into a system that makes it available for analysis, right? And so what we're doing is, it's the classic AWS story, undifferentiated heavy lifting, in this case for ETL. So what we do is we catalog your data sources, we identify your formats and data types, we handle errors and manage and scale resources. Those are the sorts of things lots of people, miss in, when they're coding the happy path, and just generate code and execute ETL jobs. Now, at that level, this sounds pretty generic, right? Next slide's also relatively generic, right? So what does Glue consist of? It's a data catalog, it's job authoring, and it's orchestration, job execution. So, where's the magic? Why would we do this? So let's get into it in a little bit more detail. So let's talk a little bit about the catalog. And what the catalog does is that it's a system that lets you discover and organize your data sources across your various silos and across S3 or your other repositories that have semi-structured data. The basics of the catalog is simple. It's a Hive metastore, or it's compatible with Hive metastore APIs or Hive SQL. And that means that you can access tools like Hive, Presto, Spark, and a variety of ecosystem tools that are compatible with the Hive metastore. We've added some extensions. You can search it. You can supply connection information to JDBC sources. And you can do classification for identifying and parsing files. You can version your metadata because metadata changes. So those are all basic, fundamental bread and butter for a catalog, right? We also crawl your data, if you let us, right? And you can certainly use Hive DDL, bulk import, but crawling is where one of the areas where what we do is different and differentiated. So let's dig into that a little bit. So what crawlers do is that they auto-populate your data catalog. The first time I saw the UX design for the catalog, I told them, I hope you're not going to take me through some wizard experience where I'm going to like click, 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 and define a table and the data things, because I'm just going to burst into tears doing that 10,000 times. And they handed me a box of Kleenex, and then I went back and started to work on actually what the product should look like. So what we're doing here is automatic schema inference. And so we have a bunch of built-in classifiers that detect the file type, extract schema, record structure, data types. And so, how do we detect file types? So, it turns out that CSV files, if you do a frequency analysis on them, they contain a lot of commas. Surprise, XML files, a lot of greater than, less than signs, et cetera, et cetera, et cetera. So you might have to run a handful of these to figure out which ones you should try parsing first, but it's not that hard. More interestingly, beyond our built-in classifiers, you can add your own and share them with others in the Glue community. It's all Grok or Python that we're running underneath the covers. And I think sharing is an incredibly important part of the Glue experience, because you don't want to be, request 473 in my backlog, right? And that's one of those things that forces you into hand coding, because if the tool doesn't do it, what are you going to do except build it yourself? And even if it's missing 5%, you end up having to do 100%. So you're much better off if you have a system where you can just code that 5% and introduce it into the system. We also auto-detect Hive-style partitions, grouping similar files into one table. We'll run crawlers on a schedule to discover new data and schema changes. And of course, the word of the day or the word of the conference is serverless. You should only pay when your crawlers run, right? Not have resources that you're paying for even if things aren't running. Let's dig in a little bit more into crawling and classification. So let's talk about how automatic schema inference works. So let's say you went and you parsed something out. You've got a bunch of different per file schemas. You recognize that there's char and int and a variety of different things. And that might be your per file schema. So you need to understand that. But then you want to unify that schema potentially into what is the union of, right? Because your data does change over time. People do have slightly different formats in each of their tables or their files, but you want to look at it as though it's one table. At least most of the time you do. And so you can see here that there are custom classifiers that you can add to. Maybe you have an application that emits logs. Maybe you have a metrics parser. There are a bunch of system classifiers, JSON, CSV, Apache, various Grok stack that you might be familiar with. We also detect partitions. So if you have a S3 bucket hierarchy where you have one level of partition that's for a month, and then for date within the month, and then you have a bunch of files there. When you generate the table, the directory structure is actually data, right? You want the month to get extracted into a column. You want the date to get extracted into a column. And then you want the file structures that are in there that might not contain month or date to also be extracted into columns, right? And so what we have to do there is estimate the schema similarity amongst the files to handle semi-structured logs and schema evolution and so on. And because it's possible that someone stuck the wrong file into a S3 bucket. Sure, it hasn't ever happened to you. It's happened to me. So how do we just figure out schema similarity? So, wow, I'm just blowing through these slides. Anyway, so that's basically two things. The idea here, this is the heuristic we're using now. I'm sure it'll evolve over time. A lot of this process is getting feedback, understanding what's happening, where we make mistakes, figuring it out, and iterating. I mean, that's the AWS way. But what we're doing right now is we basically have a simple heuristic where we figure out, well, does the name match? Does the data type match? And across these two files, does enough of it match that we should look at the intersection over the, the minimum number of elements? And if it's over 0.7, and is what we're doing right now, we say these files are similar. It's part of the same table. Okay. Make sense? And of course, just as you'd expect, you can go and override stuff. You can choose not to run classification. You can go and enter it yourself. You can use API to enter in table definitions. You can import, export into other catalogs, whatever. Certainly, if you're extracting from databases using our JDBC connectors, then it's canonical. It's well defined. All of this stuff is, what we're focusing on here is the messy part of semi-structured data, where people are just throwing files into a big bucket, and you have to go and figure out what's there. So let's talk about job authoring. So the key here is to make ETL job authoring like code development using your own tools. So it's almost the opposite direction of the ETL tools I'm familiar with anyway, which are very much Canvas UIs and are oriented towards data scientists or IT staff. So I mean, those guys do that stuff well. There's no reason to try to supplant them. But what we're really focused on is the portion of the market where people aren't using them. Okay. So the basics of it is that you provide a source, you provide a target, and we go and generate code, Python code. It runs inside a Spark container, so it's scale out. You can schedule a triggering condition like a calendar or a Lambda event or some other criteria like pressure, like enough of these files have ended up inside S3, which you can do, again, using Lambda or some other trigger. And so at this level, a lot of people, given the source and target, will generate a graph that looks like that. Let's dig in a little bit on what we do. So what we're doing is we're generating Python. The graph is actually a bunch of annotations inside the Python. So when you edit it, you can add your own elements and annotations and update the graph, right? So so those things can stay in sync. Obviously, if you mess it up, the graph's not going to make any sense. It's very much like JavaDoc, right? If it's a sort of a shared responsibility. If you provide the information, the graph makes sense, but at least you can edit, right? And editing is the core to this, so that you edit the pieces you need to, and we generate just the generic stuff that you want, like extract, error processing, et cetera. So we're running on PySpark, as you'd expect. We handle bad data and crashes, so bad data moves off into a bucket, and you can go and deal with it tomorrow rather than have your job fail and get paged in the middle of the night, as happens altogether too often. And it'll adapt to source schema changes, and you can specify whether you want the target schema to change, or more likely, have that file also end up in the second location, so that you can evaluate whether the next day you want to deal with that. And we'll handle complex semi-structured data. So we can talk a little bit about that, what that looks like in a minute. So I mentioned that we have human-readable annotations that correspond to the ETL graph. So you can see here that there's a type, there's a return, there are inputs to it, and there are a bunch of arguments, and that basically is what I need to generate a graph. And in this case, it's basically saying, make the object look like a data source element, and hey, there's nothing that's a predecessor, right? So relatively straightforward. And beyond that, we have the basic notion of frames in Spark, if you're familiar with Spark, but it's slightly enhanced to support dynamic frames because the the tuples actually change as you go from step to step in the transform. And we deal with item potency. These are the sorts of things that people don't code in when they're coding the happy path, right? And so item potency means that a job restart is going to pick up from where it left off rather than duplicate your data in their target system and mess it up. We'll tag bad data so that we flag it and we don't crash the code, and you can choose to siphon the error tuples off at any step into an S3 bucket and deal with it the next day. So let's look at a semi-structured schema and look at relationalization of it. So that's a very colorful chart. Anyway, so here, in this case, you've got something which is a single value, a pair of values, a structure with X and Y in it, and then an array. So what you'd want to have happen here is you'd want to have a table that contains A, B1, B2, C.X, C.Y, and then you'd want to pivot into another table that has a foreign key primary key relationship to represent the array, because that could be arbitrary size, and you don't necessarily want to create columns for it. So we'll do this stuff on the fly, basically flattening the structure so that you can support relational tables. We pivot the arrays, we modify the mappings as the source schema changes, and we'll modify the target schemas if you allow us to, which you may want if you trust the source data to not have errors, which you might for things that are coming from canonical sources like Twitter or Salesforce or what have you. So that's clearly a developer screen because it's white text on a black background. And all it is here is an IDE, right? Maybe it's your favorite IDE, maybe it's one you hate, but you can choose to use whatever you want. So once we generate the code, we throw it into your preferred Git repository. We push it to the repository when it's generated. It gets pulled when before the job runs. And in between, you can run your favorite IDE to edit it as you please, right? And that means you can add new information, you can add new steps and try the transform stop process and so forth, right? Here again, we try to leverage the community. Now, our take is that there are a couple of million AWS customers at this point. Almost certainly somebody's already had to recognize your file or deal with a format or whatever. Maybe Netflix or Amazon have some interest in sentiment analysis on, comment fields, right? You'd think that they would. And, rather than having to crack open some data science book and write your own, human parser to, language parser to figure all of that stuff out and, do it from scratch, maybe I can borrow some code, assuming that people are willing to share. And I think, my experience, at least with AWS, is a lot of the developers are happy to share. And then you can choose whether you want to or not. Maybe if you're a bank, you want to share within the bank, but not, with the broader community. But maybe if you're not, it just gives you acceleration. And, you can search for classifiers here, transforms here, scripts here. We expect over time to add ranking, recommendations, reviews, all that, all the stuff you'd expect, right, certainly from Amazon, .com, right? So I think that that'll help a lot for people. And, in particular, I think the world's getting complex, right? You might think, oh, I can write something that does sentiment analysis and then remove curse words, and then I'm dealing with that for the English language. And then it turns out that now my hotel site is supporting Turkey. I don't know Turkish. I don't know the curse words in Turkish, And so, but probably somebody does. Maybe they've put something in. At least I should look at that first before I, break out my Turkish to English dictionary. Keep going. Let's look at orchestration and resource management. So now we've generated a catalog. So we know what data we have across all our various sources. We've generated an ETL job that we've tested, and we've done unit tests around, and pushed it through a pipeline against sample data. We have some confidence in it. So now I'm ready to do a pipeline run. So here what we're looking for is composing jobs together in a pipeline. And so what you're looking for is I ran this job, this other job is dependent on it, this third job is dependent on the first job, this fourth job is dependent on job 2 and job 3 completing successfully. If job 3 doesn't complete successfully, I want to run job 5, all that stuff, right? There are also different ways to trigger a baseline, so I just talked about dependencies and having the system automatically develop that once you define the basic step-to-step inference, right? And that's just about you define the prior dependency and we'll generate the overall dependency graph as long as it's directed and acyclic, right? You can do schedules here, time of day. You can do event-based. You can do external sources, and that I think all gives you a fair bit of flexibility. I'm sure this will advance over time as we have requirements from our customers. Dynamic orchestration is an area that's interesting. One part of that is simply dealing with faults and retries. Another part of it is dealing with data pressure to say like, oh, today's job is bigger than yesterday's job by a lot, so I want to run it on a wider cluster. And one of the ways that you do that is you have to actually start reading the data in order to figure out it's larger or smaller and scaling things. So that's one of the things that might be dynamic. Another thing that might be dynamic is to say, oh, when this condition happens, I actually want this other job to run, right? That I normally don't want to have happen as part of my normal thing. And so that gives you, again, a lot of flexibility. This also is serverless, so there's a warm pool of instances. You don't provision them, you don't configure them, you don't manage them. You deal with jobs, and we deal with infrastructure. We'll basically take our warm pool, create ENIs and attach them to your VPC, and it will give you enough nodes to handle your SLA and cost objectives. And again, you pay for the resources when you consume, when you're consuming them, not otherwise. And that just makes sense, particularly for ETL, which generally, for most people, isn't an always-on type of process. Monitoring metrics, notifications. So, this is, again, sort of bread and butter stuff. You want to track your pipelines. You want to track your job history. You want to see how things change over time. You want to see when runs failed or succeeded. And the graphs at the top show you all of those points. The red dots are the ones that are failures. And so you can go and quickly target it on failures, rubber band in, and use that as a selector for the list, and then go and figure out what's going on here. So in this particular case, there's an alert saying that, hey, this job took a lot longer than other cases. There might be things about like, oh, there's like 95% error rate on this thing. I'd probably need to go look at that because something went bad. Now, there's a lot of stuff in here that, again, is just bread and butter. A lot of people provide it. It's just necessary stuff for anyone to do. So that's the basics of what we're doing. This is early days for Glue. There's a sign-up sheet. You can sign up for it now. We should be opening the preview reasonably widely in another month or so. And I think the release should happen in the first half of the year. It's not going to go out until it's ready. It's not going to be ready until a bunch of customers tell us it's ready, right? And so the stuff isn't straightforward. There's a lot of data sources. There are a lot of error conditions, et cetera, et cetera, et cetera. We just want to make sure that when it goes out, it's good. All right. Thanks a bunch. There are feedback forms in the back. I'm happy to take Q&A. There's like 35 minutes left. Also, outside there should be a pile of temporary tattoos, metallic, that you can put on before the party. And there are 2 sheets in each one you can share with a friend. Yeah.